All right, so we're talking about ratios and proportions, and ratios and proportions are connected to each other. So a ratio shows the relative sizes of two or more values. So we might talk about the ratio of boys to girls or the ratio of red cars to blue cars. Um, and when we write a ratio, we write it either as with a colon. So we would say that 3 to 1, or we might write it as a fraction, but the denominator of the fraction is going to be the entire amount of things. So in this case, if there were um, 3 apples and 2 oranges, then 3 out of 5 pieces of fruit are apples and 2 out of 5 are oranges. As a decimal, we can write that as zero point 0.6 are apples, and so then zero point 0.4 would be oranges, or we could also say that 60% are apples. And then a proportion is when we take two ratios and we make them equivalent. So here's an example. A recipe calls for 2 teaspoons of baking powder for every 4 cups of flour. Kristen only has 3 cups of flour. How many teaspoons of baking powder will she need to use? So we need to set up our ratio first, and it doesn't actually matter which one goes first, baking powder or flour. So I'm going to say 2 teaspoons of baking powder for every 4 cups of flour. So the ratio of baking powder to flour is 2 teaspoons to 4 cups. And I want to know what number would go in here if she only had 3 cups. So what I can do is I can set that up as two equivalent fractions. So the number of teaspoons goes on the top, the number of cups goes on the bottom, and then at this point we just are going to cross multiply. So when I cross multiply 4 and 6, I get 4x, and then 2 times 3 is 6. So now I just have to solve for x by dividing both sides by 4, and x equals 6/4. And I can either simplify that down to 3/2 of a teaspoon, or I can go ahead and say 1.5 teaspoons. 3/2 for the purpose of measuring is probably going to be easier because usually you have teaspoons that come in a half a teaspoon. All right, so let's look at another example. Example 3, Cole has noticed that the number of a particular bird in his backyard decreases by 1 for every 5 degrees the temperature outside increases. So as it gets warmer, fewer of these birds show up. If the weather forecast is calling for a 25-degree increase in temperature over the next week, how many fewer birds would Cole expect to see? So we have a decrease of 1 bird for every 5 degrees. So I'm going to set up that ratio. 1 bird to every 5 degrees. We know that there is going to be a 5-degree increase, a 25-degree increase in the temperature, and we want to know how many fewer birds he should expect to see. So if I go and turn this into a ratio, I've got 1/5 equals b/25. I'm going to cross multiply. I get 5b equals 25. And then I divide both sides by 5, and I get b equals 5. So he would expect to see 5 fewer birds if the temperature increases by 25 degrees. All right, so let's look at number 4. Marissa hosts a pottery class. She has found that for every $4 she increases the price, one less person comes to the class. If she raises the price $12, how many fewer students would she expect to have? So for every $4 she increases the price, she loses one student. So if she raises the price $12, how many fewer students would she expect to have? So I'm going to go ahead and set this up again as a two fractions where I can cross multiply. So two division problems where I can cross multiply. Okay, and then I'm going to cross multiply, and I get 12 times 1 is 12 equals 4 times s. I divide both sides by 4, and I get s equals 3. So she should expect 3 less students, or 3 fewer students. Okay, and then somehow I managed, just in the scrolling, to miss a problem. So I'm going to scroll back up to example 2. Sorry about that. All right, so two gears are connected, and this really happens. Two gears are connected. When gear A, so this big one right here, when it turns gear B because they're locked together. Gear B, because it's smaller, makes 3 rotations for every 2 rotations that gear A makes. If gear A makes 38 rotations, how many times does gear B rotate? So I'm going to say gear B makes 3 rotations for every 2 rotations gear A makes. So I'm going to set up that ratio 3 to 2. If gear A makes 38 rotations, how many times will gear B rotate? All right, so I'm going to set up a ratio here. 3 over B equals 2 over 38. And then I cross multiply, and I get 2B equals 3 times 38 is going to be 114. Let me double check them. Yep. Okay, and I'm going to divide both of those by 2. And 114 divided by 2 is 57. So B equals 57. So if gear A rotates 38 times, then gear B would rotate 57 times. Okay, and that's it. So to solve just to recap real quick, to use cross multiplication to solve ratio questions, you have to set up some division problems. They look like fractions, but they're division problems. Because anytime you divide the two pieces of a ratio, you should get the same number. So 2 divided by 4 should be equal to x divided by 3. So you set up those division problems, you cross multiply and solve for your missing variable. And that's it. So some important words you might look for are things like ratio, proportion, proportional would be another word. Proportional. If it says that something has a proportional relationship, then that means that it's basically that all the ratios are equivalent. Every time something happens to one, the same thing happens, or something else happens to the other one, and it's a predictable amount. You might also see something like the constant of proportionality. All of those things just mean ratios and proportions.